The following is a soil test that was conducted by an NRCS soil scientist in eastern Boulder County comparing two different soil types and their ability to uptake moisture.
And so what we're doing is we're testing two different kinds of soil to see their abilities to hold and utilize the water. So we're pouring infiltration water, yeah. So what we're doing is we're pouring equal amounts of water and equal amounts of soil. You can see the runoff. We're seeing what it's doing with the runoff. We're seeing how much it's going to infiltrate. You can see here, this is some of the soil that where they do, you know, there's no soil health, there's no cover crops on it. There's not any rhizome debris or anything like that in the soil, and you can see it runs right off. Same amount of soil in healthy soil that has armor on it. There's a lot of biology and life, a lot of worms and stuff. This one here, no worms. There's probably very minimal micro, you know.
Taken 100 yards apart in the landscape.
100 yards apart. This is, okay, and we're just looking at what you can see. The infiltration test is to see how much water goes through.
Biological glues. The foam that you see is glomalin. It's polysaccharides, different carbohydrate, humic and fulvic acids, different complexes. That is basically old glues that were holding these minerals together that haven't been recharged by living roots, so they get really weak, and when they go under disturbance and change of moisture from dry to moist, they disperse and the sediment all goes in suspension and the glues foam up. It has a lower bulk density, so it floats above the water, and you can see it there where this one has hardly any water. It was about 1.5 inches. We simulated about a 6 or 8 inch rainfall event that would have happened in you know, maybe about an hour's worth of time at the speed that we were infiltrating.
Well, and as you can see, this water here that ran off in, I just wanted to show the tray below where it should have went through the soil strata.
Infiltrated.
Yeah, and infiltrated through that strata and should have ended up in here. There's no water in there.
This one.
And then this one, you can see all the water we poured, which were both equal amounts, infiltrated through this soil that has a lot of organic matter in it. You know, better taken care of soil. There's a lot of organics in it, where this one has none, and you can see
little biological glues in this water. So the glues are intact here. They're staying active on the minerals, and you can see there's just a little bit of foam there. And also, this goes to the point when we measure rainwater, both of these soils received a 4 to 6 inch rainwater event, but look at the function of how the rainwater behaved in the soil. So it's not about how much rainwater we capture in our rain gauge, it's about how much rainwater our soils are able to capture and use and function to grow plants and to provide the energy for the soil microbes in return that they can feed our
and you can
plants as
see
well.
therenot a drip of water, didn't even make it that.
And we can do another inch. Let's push pause.
The next video will show you about approximately a week later when we had a rain event of about 2.5 inches of rain and hail.
I wonder if this is a good example of what happens when there's no cover crops. We just had a hail rain event of 2 inches of hail and rain that came through here an hour or so ago. It really, as you can see, all the water running off everything, and because there's just nothing holding the moisture. But you walk over here and see where we have our cover crops and stuff, and it's not too swampy. It looks like our soil kind of took it up. I wonder if this is a good case of saying, hey, cover crops do help retain water, you know, instead of it all running off.
So the following couple videos will illustrate why monocropping, extractive industrial agriculture is decimating and destroying our soils here in Boulder County and causing more climate change than sequestering carbon. So here we have dead soil. EIA. Same soil. Process of bioturbation, as you can see. So that last video clip was showing some dead soil. This also had a sugar beet in it, and Boulder County was told how growing sugar beets will increase soil health. You be the judge.